I'm Ruidong. I'm working for the Premium project in Sheffield Hallam, and this work is in collaboration with the Uni of Manchester. So this work is basically inspired by our neuroscience findings, because human can have extraordinary ability to learn by imitations. So simply visual cues can efficiently trigger the imitation behaviors. So a key milestone is in motor bubbling, where the human or the infant can do motor bubblings to learn the vision and perception coordinations during the motor bubbling phase. Okay, so afterwards, a significant finding is the mirror neuron system in humans, where the mirror neuron system can activate a specific neuron when observing a human movement, a demonstrator movement, and they can associate such observations into their own internal models developed through motor bubbling phase. So building up upon this learning principles, we propose a cognitive framework that allow the robot to interpret for and imitate from a sparse event frames. Okay, so here's our methodology. So basically, we have it's a totally self-supervised learning approach. We have a multi-rational autoencoder module, so that it's learned from the robot motor bubbling phase. So we have a iCub in the Mojoko environment, and we have a RGB camera and the event camera on the top of the robot. So we let the robot to do the motor bubbling, so we can build the vision and perception associations in the latent space through the MAV the rational autoencoders. So also we have aligned event visions. Here it's not very clear, but it's a sparse event streams. So we use metric learning to force the latent space of the event vision to be close enough to the agent vision's latent space. So by doing so, we can use event visions to trigger the perception states and also the more dense images, like 2D images. Okay, so here's an example, the result we got. So here's the event vision, or the event frames of the iCub arms. Because the event vision only triggered when the motions happens. So the event vision can be triggered into a more dense RGB frames. And also we can retarget the iCub joints. This is a ground truth values. So we have a quantitative result of retargeting, which retargeting means we can translate the event frames into the dense frame with its corresponding perception states. Currently, we have the states include the joint states and the end effector poses. Okay, so yeah, that's it. Thank you.
Can I ask a question?
Yeah.
When you convert event frames to dense frames, right?
Yeah.
So is it real time, or like how much is the latency or delay?
In real time, yeah.
Okay.
But because it's not event streams, it's event frames.
And what's the size of the event frame? Like for how long you are accumulating the events?
Currently, we set up we accumulate event streams in like 20 milliseconds.
Okay.
20 milliseconds to get to the frames.
I think 15 to 20 is like kind of standard.
Yes, yeah. Okay.
Thank you.
Thank you.